In Unit 5, we'll be calculating the different shapes and materials required to withstand different types of loads. For the most part, we'll be using an A36 steel and I-shaped beams, in particular the W-shaped beams. If you go to example 1, you'll see that we have a 18-foot steel beam with 2 concentrated loads of 8,000 pounds at the third points and a uniformly distributed load of 400 pounds per linear foot. I've already filled that out here on the Excel file that you'll be downloading. I split the load one, that's going to be my distributed load, to having just the pounds per linear foot and then the calculated total weight of it. So you can use those as you wish. Then everything else is kind of laid out the same way. The FB, your allowable bending stress, which all the different shorthands for all the different properties of a steel beam are located in this nomenclature chart. So there's a lot in there. You can read through those as you wish. There's only a couple that we'll probably end up really using, and one of them is this FB, the bending stress permitted. So going back down to example 1, I calculated the reaction 1 and reaction 2 already. Because this beam has the loads evenly distributed, we just take the total load and divide it by 2, and that's your reaction 1, reaction 2. Maximum moment, since we know that because it's equally distributed, the maximum moment's going to be at the very center of the beam, and that would be half of 18, so 9, and that's what's being calculated out here. Another way to go about it is I took cases 2 and 3 from table 3.1 from unit 3 and then added them together. So this is the formula when you have 2 equally distributed concentrated loads, and this is the formula for when you have just a distributed load on there. So if I plug that in here, I might have to reformat these cells, so I'm going to take 8,000 times 18 divided by 3 plus 400 times 18 squared, because I'm going to take it times 18, or I guess I could do it take it times 18 times 18, or I could just use instead of doing the 400, I could probably just use this one since I already did that there, times the 18 and then divided by 8. Press equals, and that gets me the 64,200 foot-pounds. Moving forward, we're going to convert each of these into our moments into inch-pounds, so just simply taking this times 12. Let me kind of tidy this up a little bit. So now I know that my maximum moment is 770,400 inch-pounds, and then finding my second section modulus with the flexure formula of S equals maximum moment over our allowable stress. So that's going to be our maximum moment in inch-pounds divided by 24,000 psi. I didn't press divided. This 24,000 psi you can find on table 5.2. So click there, and that is under the bending stress. We can see that it is right here. Our A36 steel is 24 KSI, or 24,000 psi. Now that I know that this is our section modulus is 32.1, I can come over to this table here and search for, under the section modulus column in the x-axis, for the x-axis, search for something that is greater than the, let me go back and look at that real quick, greater than 32.1. So I'll come over here. I will, let's see here, I want to, one second, I want a greater than 32.1. And okay. but then that's a lot that's greater than 32.1. So let's say between 32.1 and less than, let's just say 40. So now I've kind of narrowed that down a little bit. I have these choices here. So the first number is the height of, or the depth of the beam, and then the second number is the pounds per linear foot. So we typically want to select the one that weighs the least as our beam we want to do. There might be occasions where there is a height limit to what you need for a beam, so that's where, so in this case I would say maybe I needed it to be shorter than 12, so I'd pick this 10 by 30, but this one right here, the 12 by 26, is going to be my lightest choice. So I'm going to come back over to my example, and there's a drop down on this guy here, and I'm going to look for 12 by 26. It should be kind of in numerical order. 12 by 26. So that's how you're going to, there's a list of problems that you're going to run through and do this. I'm going to show in another video here how to use SolidWorks to check your answers.